way we grow and produce food is ever-changing, shaped by consumers and the climate in which we live and farm. Research at all points of our food system is essential for continuously improving food's journey from farm to table. The Manitoba Agriculture and Food Knowledge Exchange explores timely research innovations and applications that make our food system better than ever. Join us for today's podcast.
Hello and welcome. This is ChangeMAKErs, a Manitoba Agriculture and Food Knowledge Exchange, otherwise known as MAKE, podcast series with me, Chantal Bassett. In each episode, we'll chat with an academic member of the Faculty of Agricultural and Food Sciences at the University of Manitoba to find out about the research and innovation they're working on and how this is shaping agriculture and food production in Manitoba and around the world. Now, as the research facilitator for the faculty, I get to work with all our incredible innovators, and I think it's high time for you to also get to discover their research as well as get to know the person behind these discoveries. Today I'm joined by Dr. Nandika Bandara, our very own Tier 2 Canada Research Chair in Food Proteins and Bioproducts and Professor in the Department of Food and Human Nutritional Sciences. Thanks for joining me, Nandika.
Thank you, Chantal. Thank you for having me.
So Nandika, before we get into the details about what you study, please share how you got to where you are today.
Thank you, Chantal. So I was born in a country called Sri Lanka, which is a beautiful tropical island in Indian Ocean. The system that we have for the higher education, we have to go through 2 competitive exams before we get into the university. In the first examination, which is equivalent to junior high type of exam, we have to select a specific field to study in the high school after that examination. So at the time, I had 2 of my, I would say, long-distance cousins, all the guys who were staying with us, who studied at the Faculty of Agriculture, University of Peradeniya. They decided to take me to one of their exhibitions they had to commemorate the 50th anniversary of Faculty of Agriculture, University of Peradeniya. And when I visited that faculty, I was amazed by all the agricultural innovations, all the big cattle, sheep, and all the other things that they were doing. And that gave me the idea to study agriculture. So for my high school, I basically select the agriculture as field of study. So after completing my high school study, which we have to go through a competitive examination again, I was selected to the same faculty that I went as a kid to see that agricultural exhibition. So I joined with the Faculty of Agriculture, University of Peradeniya, and completed my undergraduate degree in agriculture, specializing in food science field. After that, I actually took a little bit different path. So before graduating, if I remember correctly, 1 month before my graduation, I joined with an agrochemical company to work in a marketing division as a brand executive. After that one, after working for that agrochemical company for 2 years, I joined with a completely different sector again, and I joined banking. I worked as a bank manager for almost 2 years, and then decided to come back to studies and do a graduate school in University of Alberta, Canada. So my wife was doing studies at the time, so she basically convinced me to come and start studies. So I came to University of Alberta, started my master's degree in food science, and then complete my PhD in food science at the same institute. And during this time, I was really interested in working with the protein as my main research area and working on the innovations that we can bring in from the other disciplines, especially in the areas like material science, nanotechnology, chemistry. What can we get towards like improving the food industry or the food science? So that's how I get into the research that I'm doing right now. After my PhD graduation, I got the postdoctoral fellowship in the NSERC postdoctoral fellowship, and I went to the University of Guelph Food Science Department to continue my postdoctoral studies. However, I got a faculty position at Dalhousie University at the same time. So I only stayed in Guelph for, I believe, 5 months, and then moved to Dalhousie University to start my independent academic position. So I was hired as an assistant professor in food bioscience. I was there for almost closer to 2 years. And then there was a advertisement. There was an advertisement related to the Canada Researcher in Food Protein and Bioproducts at the University of Manitoba. So I decided to apply for that one because that's where primarily my research was happening at the time. So that's how I ended up in University of Manitoba.
And Nandika, we sure are glad to have you. Can you tell us a bit more about the focus of your research, the fact that it is interdisciplinary, and what challenges you're trying to solve?
Thank you. That's a really good question. Unlike most of the traditional food science field, as I indicated earlier as well, I'm trying to work with different disciplines and bringing the knowledge from those disciplines to advance the field of protein innovation. So in terms of my main research, I have three main research themes that's currently working, like we are working in our research group. Overall objective of all the research happening in our research group, our Food Protein and Bioproducts lab, is related to improving or advancing the protein innovations, trying to find value-added applications to the protein industry, especially in Canada. As you may know, we do produce some of the pulses and other oil seeds. We're leading producer or like second largest producer in the world. But unfortunately, we don't really process them. We basically send them towards the other countries as a bulk commodity for processing in different places. And sometimes we even import them back as ingredient. So some of the advances, some of the innovations, or some of the research that we are doing right now will be trying to tackle those issues. Can we process those materials? Can we process those pulses or oilseed within Canada and use it for value-added application? That would be the primary objective or the overall area that we are working right now. In terms of specific themes, as I mentioned, we do have three primary research themes in our group. The first one is about the sustainable ingredient processing area. So under the sustainable processing area, we worked on protein extraction, both wet and dry fractionation technologies, with a special focus on sustainability. Most of the protein processing, especially wet processing technologies, right now we have in the commercial scale, focused on using high amount of water or using large amount of chemicals or working with extreme conditions in order to get the plant proteins out of the plant matrix. All of them are working commercially fine, but at the same time, with all the advancement or the interest in sustainability, we need to find innovations that are more sustainable, using less resources, and some of them can be recycled. So we are working on one specific technology called deep eutectic solvent. Even though it's new to protein industry, this is something that used in other industries in the past. So we work with this technology, we work with different oilseed and pulses and manage to develop this deep eutectic solvent-based extraction into a certain level that it can actually compete with commercial extraction method in terms of the protein quality, purity, and the extraction yields. And in terms of the function, it's sometimes even better compared to the other extraction methods. So that's just one area of under that protein ingredient processing theme. The second area we work under that theme is about using new technologies, especially non-thermal technologies, on modifying these protein. Dry fractionation is a great technology in terms of making protein ingredients. But the challenge is with dry fractionation, there is a certain limit that you can go in terms of protein purity, maybe 55 to 60%. Best case scenario, 65%. Can we get the same protein functionality by modifying it with some non-thermal technologies? That's what we are trying to do with technologies like atmospheric cold plasma or pulse electric field processing. So the basic idea is we're not going to heat the protein, we're not going to do any thermal treatment, but instead we're working with room temperature, especially a technology called cold plasma, and trying to optimize the functionality of the protein ingredients that we're extracting. So that's the second main area that we are working in that protein ingredient processing theme. So our second big theme under that Food Protein and Bioproducts lab is about using protein for health. So don't get me wrong, when I say protein for health, this is not about the nutritional quality. So for something like that, I usually collaborate with some of the colleagues we have in the department. But we are trying to use protein as an ingredient or a component in nano delivery of some of the bioactive molecules or drug molecules. So that's a little bit different from consuming protein as a food ingredient towards our nutrition. There are like 100 different ways or technologies developed over the past few years in terms of using protein for nano delivery applications. But the difference that what we do is we are trying to use protein, combine it with lipids, which is not easy as it sounds. You basically cannot like combine two things that don't like each other. But we are working on conjugating or combining that lipid and protein together, and then using that one to encapsulate bioactive molecules and drug molecules which have different chemical properties. For example, if you take something that can be easily soluble in water and another chemical or a drug molecule that will be soluble in lipid, you can't put them in the same encapsulation wall material if we work with one material. So that's where our research comes in. We try to conjugate that lipid and protein together and encapsulate the materials that are completely different in chemical nature in the same matrix. Just as a long-term vision, if we can basically encapsulate cannabis extract, which is used for the cancer patient as a pain management medicine, that's something that would be an example of how we can use this kind of a differently soluble compounds in the same encapsulation platform. So it will be a universal platform where you can basically incorporate any kind of material into that. Third theme that we are working in the research group is all the value-added application of waste material that no one else wants. If you think about the protein processing, what are you going to do about all the hulls, pea hulls, and all the lignocellulosic material, wheat husk, or something like canola meal, which is very good in terms of the protein content, but at the same time, there is not really a value-added application except for certain animal feeding, especially with the limited applications in animal feeding. So we try to get all these byproducts and waste materials and then process them, what we call downstream processing, into value-added components. One of the examples is we work with the canola meal, which is industrially used for the canola oil production. And at the end of the canola oil extraction, they ended up with canola meal. The challenge with that is once they go through that oil extraction process, all the protein remaining in the canola meal is completely denatured and you can't really use it for the food application. So with that, we try to use those kind of a protein and even other lignin and cellulose part towards developing something like packaging materials or using poultry feather as a byproduct to make wound healing materials. At the same time, all the lignin and cellulose that we cannot really even feed to animal, we basically break it down, make them into something called nanomaterials. For example, cellulose can be broken down into really small particles called nanocellulose, and then we can modify those cellulose particles and use it in those packaging materials that we are developing in the lab. So we did work on some of the nanocellulose-based packaging materials very recently, and that's some of the example in terms of our third research theme that we are working on.
Wow, Nandika. So it looks like you have no one set end goal. You're looking at the whole spectrum. So you're looking at, let me get this right, processing to make sure that it is sustainable and looking for new value-added opportunities. You're looking into microencapsulation so we can get these bioactive particles right to where they're needed for nutritional health. And you're also looking at opportunities for waste management so that we utilize Canadian crops to the best that we could. Beyond that, what impact do you hope your research will have?
Thank you, Chantal. So you basically summarized everything that I said into one line, which is great. So in terms of the impact, I think I already mentioned about some of the industry-specific impact that we are looking at. So that's one aspect. So if we can develop technologies that the industry, especially small and medium-scale industries, can use, that would be an advantage when it comes to improving the Canadian protein innovation ecosystem. That's one of the main impact that we are expecting. At the same time, if we can improve the environmental sustainability, that would be another thing, right? Like with all the hype about the environmental issues, environmental concerns, it's a good time for us to think about how we can improve or optimize the processing or the processes we have towards achieving environmental sustainability. So that would be the second thing. At the same time, one other thing that I didn't mention before is about training the people who would be required to run all these innovations in the future. So right now, I have a research group consist of 14 people, which include a range of postdoctoral fellows, PhD students, master's students, and some undergraduate students as well, including some exchange students coming from different countries during their PhD time. For example, I have one PhD student coming from University of Leeds in United Kingdom, and another PhD student coming from Istanbul Technical University, another PhD student coming from Tecnológico de Monterrey in Mexico, if I'm pronouncing that name correctly. So like that, I have several people coming into my group and getting the training in different aspects of research projects that I mentioned. The main idea is I can come up with all the ideas that as much as I want, but then we need people to work on those areas who will be going into the industry or into the academia or even into the policy making, and then implementing those technologies or trying to change policies based on that. So that HQP training or the training the next generation of protein scientists is one of the biggest impact that I have. If I'm allowed to brag a little bit about that. I'm very happy to say about the achievements some of my trainees are getting. For example, one of the master students who just completed her thesis in canola protein-based sustainable packaging materials won the Distinguished Master's Thesis Award within the Applied Science category. So the entire University of Manitoba awarded 5 master's thesis prizes in different disciplines, and she managed to win the Applied Science category award. When it comes to the national and international conferences, our trainees are winning awards in multiple locations. For example, if I start with the Institute of Food Technologies, for the last 2 years, we have one person at least winning an award in graduate student research paper competition. And this year, there was a protein innovation challenge. Group of my students compete in that one and won the third place in the Future Protein Innovation Challenge organized by the Institute of Food Technologies. When we talk about the Canadian Lipid and Protein Conference last year, they did have a graduate student research competition where they selected 10 people for the final competition. 4 people came from my group, and we won both first, second, and third prize during that competition. So those are some of the examples. And within the university, Manitoba Institute of Materials Conference, both first place in PhD and first place in postdoctoral category and overall first place won by people in our group. So these are the training that the students get, and they showcase that they can be the leaders in the innovation for the future. And when it comes to training those people, my approach is not just to train them towards the research. Yes, they're winning research awards, they're winning presentation awards, that's great. But I want them to be the leaders who can lead the innovation for the next decade or going into industry and lead that industry. I'm very happy to say that I have not just one, 3 people over the last 3 years at the University of Manitoba winning Emerging Leaders Award at the University of Manitoba. Every year, I have at least one person from my research group winning the Emerging Leader Award and even participating in the President Leadership Program, which indicates that they get the training not just on the research, but also on the side of the professional development, which I believe personally, because the experience that I had in my past, would be really beneficial for them to go into the academia or to the industry and become the leader who would lead the innovations for the next 5 to 10 years or even longer.
So, Nandika, what is the most interesting or surprising thing that your team has discovered so far?
In terms of the technology-wise, as I mentioned, deep protective solvent-based protein extraction is one of the things that I would say, accidentally discovered, because we weren't really planning on developing that deep protective solvent extraction as a protein extraction technology. We wanted to get the protein extracted from plant materials at neutral pH 7, and there were some past studies done from North Dakota State University and one research group from Germany who tried to extract the protein using deep protective solvents. To our surprise, their results were very, I would say, needed much more improvement in terms of the protein purity, because none of those studies could develop that deep protective solvent extraction method into a commercially feasible technology. Our goal was to get the protein at pH 7 so we can use it in the nano delivery research. So that's how we started that research. But to our surprise, when we optimized that extraction technology, we ended up in getting better results than current commercially available methods. That was a pleasant surprise for me, to be honest, because that was not our plan. So then we basically invest more time and effort on optimizing that particular extraction technology towards multiple different crops rather than trying to produce a protein ingredient. Other than that, one other thing, I think I already mentioned this, what I was surprised is how good we can convince people to develop as a professionals, not just in research, but also in different areas that they need to develop. So when I work with all the students, I'm always amazed by their capabilities, capacities, and their willingness to work towards a specific goal. None of the research that I discuss would happen if it's not for my amazing research team. They are the one who always in the lab. They are the one who always do all these innovations. I'm just giving them the support that they need. That's something that I realized, because one of the things before coming to academia, I heard is, it's really hard to work with students. It's really hard to get things done. Maybe I'm lucky, but so far I do not have that issue. And I'm really happy to say that I have a really amazing group of people who's dedicated. And that's something that I find as something surprising for me compared to what I heard before coming into academia.
So, in terms of, I'm hearing that you're not only an emerging scholar within your own field, you are training the rising stars for both industry and academia.
I would say yes. Some of the people who are coming from my group already holding leadership positions in international organizations. For example, American Oil Chemists Society, the Student Common Interest Group president is from my research group from University of Manitoba. In the Institute of Food Technologists, there are several people in the leadership positions in the student groups. So yes, they are not just doing the research, but they are leading not just at the national level, but at the international level as well.
So, Nandika, can you finish us off by telling us one thing about yourself that is unrelated to your research? Do you take the time?
Yes, I do. So, one of the things that I really like to do is playing cricket, which I did from my school time. So, I do play cricket. But other than that, one thing that I'm really like, which I know all the Winnipeggers would hate me, is supporting hockey. Not to Winnipeg Jets, but to Edmonton Oilers. So, Oilers is my team, and I always watch any Oilers game that comes in the TV channel or anywhere. So, I'm a big Oilers fan. I started in Alberta, so that's where I started following hockey. So that's what one thing I would say that most people do not know me except the people beside my house, because every time that hockey season comes in, I have a Oilers flag waving on my house in the middle of Winnipeg.
Well, Nandika, I have to assume that any Canadian would love to have the Stanley Cup back in Canada, be it the Winnipeg Jets or the Edmonton Oilers.
Absolutely.
All right, so Nandika, thank you so much for chatting with me. This has been Dr. Chantal Bassett, joined by Dr. Nandika Bandara, Tier 2 Canada Research Chair in Food Proteins and Bioproducts at the University of Manitoba. And that is it for today's episodes of ChangeMAKErs, the Faculty of Agricultural and Food Sciences Research and Innovation podcast. Join me in future episodes to hear about other fascinating research being led by agricultural and agri-food innovators at the University of Manitoba.